there's a way to make an entrance.
This is my destiny.
It was now a conspiracy of witches.
Download Veely today.
Watching TV, surfing the internet, or navigating by mobile phone and at the wheel are a normal part of everyday life, always available at the push of a button. These data come from space, where satellites ensure smooth transmission over tens of thousands of kilometers. Hardly anyone knows how complex this technology is, from building a satellite to launching and putting it into operation. Transporting a satellite into space by rocket is of itself a superb technological achievement.
At that point, then we start to relax a little bit, but not so much, because there's still a lot of work to be done.
Engineers have to produce a true masterpiece. After all, we're talking about 15 years smooth, maintenance-free operation in space. Operating a global satellite fleet is a high-tech business. Not only in Europe and America, but also in Africa and Asia, satellite communication is a central element of infrastructure and a growing market.
The space environment is something very brutal, so we do everything we can to protect our satellite, our babies, right?
Here in southern France, a marriage is about to be celebrated. The coupling of the communication and service sections as the satellite takes shape for the first time. The team around engineer Elodie Viau has worked a long time for this moment.
Building a high-performance telecommunication satellite is a very specific task. There is actually very few companies in the world that are able to do it. I'm very excited because today is the day of the coupling, and it's the first time at the end of this phase that you will see the satellite taking shape.
Engineers first check all components, right down to the lifting hook on the crane at least twice. Elements that have been checked are given pink tags. Nothing must go wrong. Later, special bolts will connect the two parts of the satellite. Not a single bolt can be out of place.
When this communication module will be lifted over the service module that will come in the middle, we visually check that there is no clash or no problem to make sure that it will be okay, because then it should work during 15 years and it's not in orbit that we can go to fix a cable or anything, right? So we need to be very careful on the ground and retest everything to make sure everything is fine.
That also applies to the foil around the satellite, which is designed to regulate the temperature, because in addition to power generation, heat management is one of the biggest challenges. In space, the satellite will be exposed to temperatures ranging from -170 to +120 degrees Celsius. Sensitive parts like cables are insulated. If the satellite is to function correctly, the interior temperature should be a constant around 40 degrees Celsius, so the interior walls are protected with layers of special foil to keep the temperature. The outer skin of the satellite is also highly complex. It's here that the solar panels will later be attached. They always turn towards the sun. Because of the great heat this entails, the outer skin will be protected by thousands of tiny reflectors, which are still unpacked. They will protect from the sun's heat. The tanks, batteries and thrusters are important service module elements. The lithium-ion batteries, which are similar to those in our mobile phones, supply enough to operate the satellite for 1 hour in the Earth's shadow, where the solar panels are ineffective. But they are the main source of power for the communication section, which receives signals from Earth.
A signal that has been a long way, 36,000 kilometers, so a little bit tired about all this distance, is going to be received by the antenna, and going through this telecommunication module is going to be processed amplify, and then retransmit towards the Earth to be able to transmit television. So then you will have the person at home, like you and me, that will receive our favorite TV show thanks to this communication module.
But that's the way in the future. Here the module is removed from its mounting with great precision. After an hour, the communication section of the satellite is free and given a final check on the ground. All components for operating the satellite are duplicated. Should one system fail in space, the backup will come into play. Only this way is it possible to ensure that all systems will function for 15 years. The two modules together weigh 3 tons. Specialists check the straight alignment of the module with a special spirit level. The slightest irregularity could cause problems.
So you need to have a good equilibrium when you will go on the service module to be able to fit it without any clash with the service module. So they will add a little weight to make sure that it's perfectly balanced.
The experts have a final team meeting. Then the decisive phase begins. Controllers observe every single movement as the module is lowered onto the service section. For the last few centimeters, the monitoring also takes place internally. The entire operation is intentionally carried out without the help of computers.
Despite that it is a very high technology, you have all the human perception that is involved. You have people checking visually, inspecting with the hands closely, and trying to check that everything is going to fit together properly. So right now we are at a very critical time, and it's very tense because it's at the right moment just before you finish the coupling. So we are about to get there, and people are all checking.
50 connections have to be established, from the fuel tanks to the outer skin. The work is performed with millimeter precision, because every connection must be perfect. Once the two sections have been joined together, some internal areas of the satellite will no longer be accessible. The marriage has already been in progress for 3 hours. But finally, after 2.5 years under construction, the satellite has almost reached completion. Now the vital signal dishes will be fitted. They look different from the dishes we see on our roofs, especially the uneven surface.
So those big dishes are actually like your dishes at home that transmit the signal towards the Earth. So this big but very light, around 15 kilograms, and it's made of honeycomb and carbon fibers. So you can see as well the shaping on the beams that define the coverage and the performances on Earth.
The signal first comes from this horn antenna. It transmits them to the circular antenna, which radiates them onto the large brown dish. From there, they travel onto Earth. Weighing 200 kilograms, the 5 transmission units are located on the exterior of the satellite. To prevent overheating, all of the antennas are white. State-of-the-art technology enables a high-performance satellite to transmit hundreds of TV channels and thus supply an entire continent with television signals. The solar panels are waiting to be fitted. By further miracles of technology, they unfold in space.
This is just a few of the 20,000 cells that are composing the full wing of the solar array. This solar array is currently stored, but when it will be deployed, it will reach 17 meters. There is 2 wings like that will actually bring the power to the satellite. In orbit, the satellite is not linked to the Earth with a cable.
LODVO is relieved. Her team's task has almost been completed. When the remaining assembly work is finished, the satellite will be tested for 6 months. Before it is launched into space, those responsible must be certain that it will function for the next 15 years. Experts spent months checking whether the satellite is robust enough for the flight and for operation in space. After 6 months, they are sure that everything functions just as it should. The 6.5-meter-long satellite is now got ready for its long journey. Another logistical masterstroke. It is placed in a special thermocontainer which regulates the humidity and the temperature of the satellite and cushions minor jolts. On board an Antonov aircraft designed for such cargoes, the satellite is then flown across the Atlantic from southern France to South America. Throughout the flight, the temperature, humidity and vibrations are constantly monitored to ensure that the satellite reaches its destination undamaged. Located in Kourou, South America, is the European spaceport. The huge rockets are launched from here. Because of the proximity of the equator, they need less fuel to reach their destination than if launched from Europe. In its hangar, the launch vehicle is waiting for the satellite. It will be taken into space by this 55-meter-high Ariane rocket in 72 hours' time. Responsibility for the launch lies with Martin Halliwell, CTO of engineering at SES, the world's leading satellite operator.
What we're doing is we're checking the thermal situation for the satellite, make sure all the temperatures are correct, either for the batteries or for the tanks or the various different technical elements inside the satellite. We're also checking that the batteries are fully charged and that we're all ready for launch.
In a special protective atmosphere, the tanks are filled with over 3 tons of highly explosive fuel. Engineers then prepare the satellite for the rocket. Every detail of the installation process is vital. The slightest error could prevent the satellite from separating. 250 million euros have been invested in the satellite and the rocket. The satellite is now in place in the upper section of the rocket. Prior to launch, further trial maneuvers are required. Even for experienced rocket supremo Jean-Yves Le Gall, first and foremost that means keeping a cool head.
Everything has been prepared and we have to decide if we can fly or not, and to decide that because it's always a little bit difficult, you don't have to you don't need to have emotion, so you have to be very basic, very objective.
For a smooth launch, every technical detail must be correct. This thruster will lift the rocket into space. Transport to the launch pad is a tricky operation. The mammoth 180-ton machine will be pulled by a truck that looks tiny next to it. The Colossus is resting on a specially built transport vehicle which runs on rails. Docking it calls for millimeter precision. Despite their experience, the team are tense. After all, this is a highly sensitive load.
We can't just set off. We have to wait for the all clear from our colleagues who are responsible for safety. And when we do head off, we've got to travel at snail's pace. We can't proceed any faster than 0.01 kilometers an hour. This job calls for a very gentle touch.
The rocket is now on the launch gantry. Just before takeoff, the 2 supply arms will fill its tanks with liquid hydrogen and oxygen. The journey to the launch pad is an amazing sight and a risky operation. After an hour, the Colossus has finally covered the 2.5 kilometers. The countdown can begin. But there's still plenty to do.
There's about 8 hours left before liftoff, and my colleagues over in the other building are actually working to configure the satellite and monitoring it and testing it to make sure that everything is set to go.
Satellite Program Manager Richard Starkovs is the most experienced specialist in the control center where all data converge. The experts always play safe, refusing to take any risks that might imperil the mission. Richard Starkovs has overseen numerous launches. Nevertheless, even he looks tense.
The tension will go down when we have separation of the satellite from the launcher and we see that the orbit is correct. It will go completely away when I see that we have a signal from the satellite, which should be about 5 minutes after separation.
Everything has gone according to plan, but just 2 minutes before liftoff, the engineers abort the mission.
Für uns alle ist klar,
we're all fully aware that none of us can take a risk, so we've postponed the launch. It's important to us to know that the satellite is safe for the time being today and will be launched securely into space later.
Sicher ins All kommt.
The problem was the weather. In the upper levels of the atmosphere, what is just a pleasant breeze on the ground proves to be an issue. A team of experts checked this with a balloon.
It launches 3 different balloons. The first one was okay. The second one was they found that the winds were too high, and at that point in time decided they would not continue with the countdown chronology for today.
A new day in French Guiana. Will the engineers be able to launch Europe's biggest carrier rocket today? After liftoff had to be aborted, it spent the night on the launch pad. The new high-tech satellite on board will supply Germany and other European countries with digital television signals. The second attempted launch in the evening is a success. An almost inconceivable thrust of 30 million horsepower, equal to that from 40 Airbus A380 engines, lifts the rocket into the skies over South America. After exactly 27 minutes, the central section of the rocket opens up and the satellite separates, to the relief of all concerned. But it's only now that the engineers' work really starts.
And so this goes on for about another 10 days to 2 weeks. So after we've separated from the launch vehicle, we go through the transfer orbit, we then raise the orbit to geostationary, and then make sure that everything still works correctly. Then we have to go through all the various different deployments. We go through the solar panels, we go through the antennas and whatever to get it ready for operation.
The rocket has taken the satellite up to a provisional orbit. It continues under its own power. Only later will it reach its final orbit. Further satellites will be launched soon.
Yeah, the business does continue to grow. There's no doubt about that. We actually have 12 satellites under procurement, so this is only part of that overall development phase that we have right now.
Positioning the satellite in space is only one important element of operating a satellite fleet. Further control is taken over by Fred Dietzel's team in Luxembourg.
This is the SOC, the Satellite Control Center. It's from here that the Astra and SES satellites are controlled.
The team here controls 25 satellites. Worldwide, the major operator has 4 of these high-tech centers. The main task involves precise monitoring of all the data transmitted, because the satellites must remain in geostationary orbit. A geostationary orbit is one on which the satellite travels at the same angular speed as the Earth. It means the satellite seems to be in a fixed position in front of the dish on the wall of your house, so to speak. That's why you can receive programs. Our task here is to ensure that the satellite really is in that position. Don't forget that conditions in space are weightless, or that the satellite is orbiting the Earth at 11,000 kilometers an hour. Together with the Earth, it makes a complete rotation once a day. The controllers receive 15,000 values a minute from each satellite, every day and all year round. An alarm sounds whenever a single value changes slightly. Engineers then react immediately.
If a satellite moves by 1/10 of a degree, the footprint on Earth shifts by 70 kilometers. So 1 full degree equates to 700 kilometers. If that were to happen, our colleagues in the Dino would get quite a few angry phone calls from customers with blank screens.
Staff at Dino, the Digital Networks Operations Center, monitor program quality. They check all the TV signals that are transmitted to the satellites and then received again on Earth. That involves several hundred signals per satellite. They transmit TV programs to homes worldwide. Dependability exceeds 99.99%. No other technology can supply such large regions so reliably. The global fleet of satellites reaches virtually the whole of the world's population. Newer and newer technical innovations also enable other services to be transmitted, like fast internet connections. Satellites are excellent for transmitting huge quantities of data. That makes them particularly suitable for broadcasting high-definition and 4K TV programs. Viewers are totally unaware of the complex operations in the background. HDTV and 4K provides even better sound and picture quality. The impressive picture sharpness is the result of a greater volume of data per image. This convinces people in their homes. In addition to Europe, sales of state-of-the-art television sets are greatest in growth markets like the Middle East. The United Arab Emirates stand for megacities, bombastic architecture and incredible economic growth. But they are also an example of the steadily increasing importance of innovative satellite technology in the Middle East, Asia and South America. The technology is a guarantee of high-quality television and also of diverse data transport. Countries receive and transmit internet signals into space via satellites. Without satellites, in many regions of the world, modern communication would simply not be possible. In daily life, they provide important current information as well as entertainment of all kinds. In this desert landscape, laying underground cables is almost impossible, so transmitting signals via outer space is a perfect solution. To this end, the world's leading satellite operator has set up a local partnership.
To give you an example, if you want to wire a city, any city in the Middle East with fiber, for example, how much time and how much effort and how much money that will cost. You can do the same thing by having the satellite. And not only cover a city, the satellite will cover a whole country, a whole continent. So the satellite will always be a good mean of distribution when it comes to broadcasting. Now, broadcasting could be TV, it could be internet, it could be data, whatever it is.
Here, television transmission plays a very special role in everyday life. With 300 minutes of TV consumption per person per day, the Middle East leads the world. In second place is North America, with almost 280 minutes. The average worldwide is around 190 minutes, and the trend is growing nearly everywhere. In many developing countries and in thinly populated regions, satellites provide the internet connection. For many people, this results in a substantial improvement in their daily lives. The access to knowledge and communication helps them solve basic problems. Like in Benin, West Africa, many African countries look like this. 60% of the 10 million inhabitants live in rural communities. Often they don't have a grid connection, neither mobile phone nor internet. This village is 3 hours' drive away from the capital, Cotonou. In the rainy season, the roads are flooded and impassable. This results in the village being completely cut off from the outside world. There's no communication network, neither terrestrial nor 3G. Help with medical care is now provided by this satellite system. It connects the local maternity hospital to the internet and a health platform.
The power is 20 watts and all the installation is running with solar energy. The antenna is connected to the Wi-Fi router, so all the people can connect in the hospital and also patients, in the case they want to connect to the internet.
The combination of remoteness and the lack of connection make the availability of medical care for the people very difficult. It often causes massive problems. The connection to the internet and an e-health platform via a satellite is a milestone for the population.
Digital communication services in this area represent a key advantage, as it enables us to exchange with doctors in the city, who can give advice on complicated cases to the local nurses. The nurses here do not have the knowledge and expertise to solve all the cases.
A doctor only comes to the hospital once every 15 days. The staff can now take care of sick patients effectively without him through being able to exchange information with experts from the capital and all around the world via the platform. The connection to the internet is provided by a satellite orbiting in outer space. This means that signals can be sent in both directions, forward to the recipient and then back again from them. Whether the internet connection is achieved via satellite or another way doesn't make a difference to the user. The eHealth platform, which provides communication with experts, offers other applications as well.
SatMed integrates into the platform tools that range from teleradiology for the management of medical images. It also integrates electronic health records or application for surveillance or epidemiologic studies.
One reason why international aid groups all around the world use platforms like these is to raise the quality of medical care in emerging nations to a much higher level. Here, in the maternity unit, an aid agency offers further education for doctors and midwives so they can help mothers and children more effectively.
Today, the main activities of FFL are focused on the improvement of the public health sector, including the detection and treatment of neglected tropical diseases. But we are also offering vocational training and social protection to disadvantaged children in Benin as well as in other partner countries.
Thanks to the satellite link and international e-health platforms, life in remote villages can be greatly improved. In this way, the communities have better access to medical care. One more reason to extend the signal pathway through space in future, for every other kind of data stream. Building and operating satellite fleets is highly complex and technical, and it's worthwhile in every respect, because the reliability, speed and quality of the satellite signals are convincing. At present, there's simply no better form of signal transmission.